This is part one of our discussion of binomial probabilities. It's a little bit involved, so be a little patient with yourself and don't be afraid to replay parts of this video over and over again to make sure you understand what's going on. So this presentation is in several parts. This is going to be binomial probability part one. There are 6 aspects of binomial probability that we're going to be talking about. This is academic presentations of binomial probability are not expressed like this, but I think for our purposes it's helpful to think of 6 aspects of binomial probability. And here you see in part 1, in the video for part 1, which is what we're doing now, we will talk about 3 aspects, and in the video for part 2, we'll talk about 3 other aspects. In this video, the 3 aspects we're going to talk about are 3 different ways to find a binomial probability. We're going to talk about this tricky question of how do I recognize a binomial problem when I see one. And we're going to learn that every binomial probability problem has 3 important numbers, n and p and x. So the first point we're going to cover in this video is just to be sure that you know that there are 3 different ways you can find a binomial probability. And they can all get you to where you need to go. But I want you to be aware of all 3 ways and what we're going to be doing. The first way is the binomial formula. And that's in page 215 of the Triola textbook. The second way to do it is using a binomial probabilities table. And that's in Appendix A of the Triola textbook. We're not going to be using either of those approaches. We're going to be using the calculator. So I'm going to be showing you how to find binomial probabilities on the calculator. And that will actually be, we'll actually be finding binomial probabilities in part 2 of the video. But we're going to walk through it a little bit. So how do you recognize a binomial probability problem when you see one? The real answer to this is practice. You're just going to have to do a bunch of problems and you will begin to become aware of the pattern of binomial problems. But let's go through it. Your textbook lists 4 requirements for a binomial distribution, and I'm pretty much just going to be reading here, and I'll throw in a comment every now and then. So these 4 requirements are a fixed number of trials. The trials are independent. Each trial must have all outcomes classified into 2 categories, which are generally success and failure. And the probability of a success is the same in all trials. In practice, this academic approach is hard for many students to apply. Here's an approach that I think is a bit easier to apply. And you'll see it says here, although it's not very academic. Actually, it's not academic at all. Most of the probability problems in your textbook can be identified as one of the following types of probability problems. Normal probability. These problems are covered in Chapter 6, and there's a very specific approach to solving them. Addition rule, multiplication rule, or conditional probability. These problems often include a table, are covered in Chapter 4, and with practice you should learn to recognize them fairly easily. Counting problems. These are covered in Chapter 4-6 and are kind of tricky, but they're usually recognizable because they often include a how many type question. Now look at C. And then there is another kind of probability problem where you look at it and say, this doesn't look like a normal probability problem. It doesn't look like a counting problem. It doesn't look like an addition rule, multiplication rule, or conditional probability problem. I have no idea what kind of probability problem this is. Well, that problem is probably a binomial problem. Every binomial probability problem has 3 important numbers, n, p, and x. Once you see that a probability problem might be a binomial problem, it is pretty easy to check. A binomial probability problem must give you three numbers, which are called n, p, and x. Here are the academic definitions of these symbols. N is the number of trials. P is the probability of success in any one trial. And x is a specific number of successes out of n trials. When you find a binomial probability, you are basically saying this. Given that the overall probability of a success is p, what is the probability that out of n trials you will have x successes? Let's look at paragraph B here. If you have trouble understanding this as a concept, there is also a mechanical way to determine what is n, what is p, and what is x. P is always a fraction, a decimal, or a percentage. N and x are both whole numbers. They can be equal, but otherwise, and this is usually the case, n is the big one and x is the little one. Also, n is usually given as information in the problem. The number in the actual probability question is usually x. And when we do part 2, this will start to become clearer. So look at C down there. Here's a tip. Every time you hear or think binomial, you should automatically say NPX. In my workshops, I drill my students on this. I say, every time you hear me say binomial, I want you to say back NPX. And I drill them. We do it over and over and over again. It's very helpful if you can get that into your head. Hear binomial, think NPX. And that, I believe, is the end of part 1 of this binomial probability presentation.